In this video, we're going to be doing an introduction to graph theory. So for most people, they've not done any work with graph theory before, so this will be completely new. This is a pretty long section, so we will break it up into several videos. So first of all, when we're talking about what we call a graph, it's not going to look anything like the types of graph that you saw in algebra. So we're not talking about an x and y coordinate and things like that. So we're looking at something like this graph. Okay, so this is a picture in which all the dots are called either vertices, or sometimes you'll see them called nodes. And they're connected by these lines that are called edges. Now, one thing in graph theory is when we talk about a line, it's a little different than a line in algebra. It may be curved. So it doesn't necessarily have to be a straight line. And in graph theory, it doesn't matter if it's straight or curved. Okay, so next we have what's called the vertex set. So for the vertex set, we're going to list the set of all vertices in a graph that are labeled with capital letters. All right, so if we list the vertex set, I'm going to put this in curly braces since it's a set. I just have the letters A, B, C, D, E, F. Typically we list them in alphabetical order, but really it doesn't matter. And then we have the edges. So the edges are described by listing in any order the two vertices that are connected by the edge. So for example, if I was looking at this edge right here, I could call that AB, or I could call it BA. Now if we want to make an edge list, we would want to list all of the edges on the graph. So what I do is I start with A, and I look at anything that comes off of A. So I see AB, and I also see AD. So I'm going to list A, B, and AD. So I've checked everything from A, so I move over to B. I've already connected B to A, but B connects to C, and B connects to E. So BC, BE, and then here we have what's called a loop. So we also have B connecting back to itself. So I'm going to list that as edge BB. All right, so I'm done with the B's, so let's move over to C. I've already listed C to B. Notice that C goes to D, but there's two choices for edges. So since these are two separate lines, we need to list that one twice. So I'm going to list CD twice. All right, so moving to D, we've already linked it to C. We've already linked it to A. The only edge we have left is DE. Okay, and then we get to E. We've already linked to B and D, but we have three separate paths to get from E to F. So we're going to have to list that one 3 times. Okay, and that should be the list of all the edges. Okay, so notice here we have what we call a loop. That's the only time you'll see the same letter twice. Here we have one where there's multiple edges connecting the same vertices, so we need to make sure to list that one twice. And then remember over here we had the 3 multiple edges connecting E to F, so we must list that 3 times. All right, so the next thing we have are adjacent vertices. These are any vertices that are connected by an edge. So for example, if I go back up from A to B, they have an edge connecting them. So we would say, for example, A and B are adjacent. All right, and then our next definition is a loop. We've already talked about this one. A loop connects a vertex with itself. So in the graph above, we have BB as our loop. All right, so the last thing we're going to do on this page is degree of a vertex. And we're going to see this a bunch of times in this chapter. So this is going to be the number of edges that meet at that vertex. A loop will contribute 2 to the degree of a vertex. All right, so I can't really zoom out, so I'm going to fold this paper up real quick. So I want to be able to look at that graph up top. All right, so I'm going to kind of fold this up here and then move that second page. And what we're going to do is we're going to look at this graph right here, and we're going to list the degree of each vertex. So if I want the degree of A, this is the notation we use, I just count the number of edges that come off of A. So I'm seeing 2 lines coming off of here, so it's degree 2. Now when I move on to B, notice I've got a whole bunch of lines. I've got 1, 2, 3, but remember the loop contains 2. So if you think of these as roads, like if this is your house, there's 1, 2, 3, 4, 5 directions you could go to leave that house. So that would be degree of 5. Now if we look at C, we're counting from C, 1, 2, 3. And then the degree of D, we're counting 1, 2, 3, 4. So we just count the lines that come off of that vertex. The degree of E is going to be 1, 2, 3, 4, 5. And degree F will be 1, 2, 3. All right, so we use degree a lot. All we do is count the lines coming off of that vertex. All right, let's move on to the second page. Here we have a lot of vocabulary. So odd vertices are going to be vertices that have an odd degree. Even vertices are evens that have an even degree. Simple graphs are graphs without loops or multiple edges. So the graph we looked at on the first page is not a simple graph. We have a loop here, so that keeps it from being simple. And then between C and D, there are multiple edges, and between E and F, there are multiple edges. So that would be considered not a simple graph. And then we have a disconnected graph. This is a graph in which one or more vertices is not connected to any other vertex by an edge. All right, so let's look at an example. I'm just going to draw this out. I'm going to start by drawing 4 vertices, kind of just in a circle. I'm going to label these A, B, C, D. And then I'm going to come over here and I'm going to write E, F. All right, so I'm going to connect A to D. I'm going to connect A to B. I'm going to do 2 edges from B to C, so we have to kind of curve those. And then let's do one from E to F. Okay, so this would be considered a disconnected graph because if I'm over here at F, I don't have a way to get over here. So if you're thinking of